At this point, ChatGPT does not need an intro. If you have used it, you have seen it do all kinds of cool stuff, like answering questions regarding your code, summarizing documents, and even spinning some wild stories. It is not perfect and can hallucinate, but it shows how far language models have come. In this video, we will go through the training process behind ChatGPT. We will dive into the nitty gritty of how ChatGPT gets trained and look at all the different stages that are involved. So, if you want to learn about ChatGPT's impressive abilities in depth and how it gets trained, watch the video till the end. Alright, let's dive deeper into the juicy details about ChatGPT's training process and how it differs from its older brother InstructGPT. Picture this. InstructGPT was all about taking just one request and firing back just one response. As simple as that. But ChatGPT is like the younger kid who takes things to the next level. We are talking interactive dialogues, back and forth messages, and it remembers what you said earlier. That's a mind blowing context retention. Now let's find the secret sauce behind the ChatGPT's awesomeness, and it's a three-course meal. First up, we have got the generative pre-training stage, where we take a raw language model and pump it full of text data. Think of it as just the foundation of it. Okay. Next, it's time for some supervised fine tuning. This is where the model learns from the data to mimic human like chatbot behavior. The final step is reinforcement learning through human feedback. Here, we let the human ratings and preferences shape the model's behavior. And remember, at each step, the model fine tunes itself based on the results from the previous stage. It's like leveling up in a video game. Each stage gets it closer to the ultimate AI chatbot. Stage 1, Generative Pre-training. In this stage, we unleash the transformer. Imagine it as a super smart stock market predictor. But instead of stocks, it is predicting text. It feeds on tons of internet data, website, books, articles, you name it, covering all kinds of styles and topics. We extract sequences from the data and tweak the settings to make sure it is nailing the prediction for the next bit of text. It uses auto-regressive sequence model. What exactly this model does? So this is the formula, some sort of formula, or is given some history of observed variables x1 through xt minus 1. The basic sequence model is trying to predict xt variable. This next step prediction isn't just for chatbots. It is used in audio waveform or even molecular RNN graphs. It's all about figuring out what comes next. In language models, we are taking words or parts of words as variables and trying to figure out the probability of the word coming next. Given some context or the words that have preceded it, the model can determine what is the most probable word to generate next. So here you can see the sentence is Alice painted her house. So Alice painted her house is the text or the context before. And now we have to figure out what comes next. So it can be different words like brown, red, because all these sorts of words are possible. But you have to figure out what's the probability, what's the highest probability option available here. That is brown because it says 0.2 probability, which is the highest. So this is how it tries to figure out what comes next. Depending on what kind of training data is used for training or architecture of the model, we can get different flavors of probability distribution. Something we can use it for question answering, we can use it for summarizing, we can use for translation also. Typically, language models are large transformers consisting of billions of parameters. Let's understand how transformers work just for a little bit. So TNN, transformer neural network, two parts of transformers, encoder and decoder. Let's take an example of a task, something like a word translation. So encoder takes all the words of English language simultaneously and spits out the word vector of every word simultaneously. What does decoder do? Decoder takes the same word vector and generate the French translation one word at a time. Every time a word is generated, it is provided as the context for decoder itself so that decoder can upgrade itself with the new information. At this stage, the model can complete text and predict the next word or sentence like a pro. And it's awesome at summarizing lengthy articles into bite sized bits. But that's not what I want. I want to chat with it about any particular topic. Unfortunately, that's just not what the model is built to do. The expectation is that model should be capable of doing chat and conversation, and that's why there is a misalignment here. So user input alone cannot always give clear direction to the model. Model is trained to output plausible completions or continuations of piece of text. So let's take an example here. If the user asks the model to explain how bubble sort algorithm works, in response to it, model can actually respond by saying explain how the merge sort algorithm works. It looks very bad from the outside, but it's not highly unreasonable looking at the training that we have done for it. In its training data somewhere, there are documents which just contains list of questions on certain topics like a software developer job interview. So here you can see these are in continuation of each other, and that's why the model can think that okay, this is the continuation of the first sentence, and that's why it can reply back saying with this incorrect statement. So now, because of this misalignment, we got to fine tune the base GPT model some more to make sure it meets the expectation. This brings us to the next part of our training stage, supervise fine tuning. Let's prepare for some question answer. Okay, so in this phase, we are getting down to business, training the model on tasks that are super relevant on what we want, like having a good old chat. But let me break it down for you. First off, we got to create lots and lots of conversational chats. So picture this. Human contractors put on a double act, playing both the user and the dream chatbot. The human acting as a chatbot gives out perfect response to each and every request. Like this, we create a huge training corpus using the conversation history. So this is the conversation history, and this is the ideal next response. Then once this conversation over, we'll take that as a whole conversation history, and then that's the next response. Okay. So now using the conversation history as the input and matching up with the ideal next response. So here is what the things get tricky. We train this SFT corpus using the base GPT model and a fancy sounding thing called stochastic gradient descent algorithm. Think of stochastic gradient descent algorithm as a coach that helps a computer learn how to win a game. First, it will show the computer how to play, what are the rules. Then the coach watches the computer and gives tips on how to improve. And after each game, the coach tells the computer what it did wrong, what and how to improve. This process repeats until the computer gets really good at the game. So these are the learning steps, and from there it tries to minimize the cost. We are nearly finished with the training, but before we wrap things up, let's discuss about why ChatGPT isn't fully polished even after all that SFT work. The problem it encounters even post SFT is called distributional shift. Output of SFT step is the expert policy, which acts like a rule book for how the model should respond to request. This policy is based on the conversations that SFT is used to train. No matter how many conversations and how many texts you feed this model, it won't have the knowledge of everything in the world. ChatGPT only possesses the information it has been trained on, like a small portion of the world that is stored in its memory. If you ask it something beyond the knowledge, it might get confused and provide an unrelated response. When it does, the training does not align well with the mistake, making it an outlier in the context of the data it was trained on. Due to this, it will treat it as its own mistake as the correct context of the next part, due to which the model starts making overconfident assertions or output, which is complete nonsense. We don't want the model to just watch and follow. We want it to be active and learn so it doesn't confidently say wrong things or produce gibberish. The learning is done in stage 3 with reinforcement learning through human feedback. Stage 3, reinforcement learning through human feedback. Human feedback, the final missing piece. So, before we get deeper into reinforcement learning, let's discuss reward function. In reinforcement learning, our agent, in this case ChatGPT, interact with its surrounding and learns the rope by being rewarded or by punished. To keep a track of how well our agents is doing, we use something called a reward function. Think of it as a scorecard that tells us if ChatGPT is acing its decision. We bring in a human agent to do some RL magic. Instead of crafting the reward function ourselves, we let the AI trainers have a chat with her ChatGPT. Then we mix it up by trying out different alternatives. So here the human agent is discussing with the ChatGPT model, and we are also provided some other alternate responses for three or four different responses. Now our human labor comes in and ranks these responses from awesome to meh. It's like deciding which ice cream flavor hits the spot the most. In these conversations, we have got pairs of request and response, and they are like ChatGPT's training buddies. The reward model, which is our RL coach, looks at these pairs and figure out which responses are top notch and figures out scores for each one of them. It gives a ChatGPT a high score when it nails it. Let's break it down. We have got two players here, the reward model and the policy model. Think of the reward model as the one giving grades to ChatGPT's answer, and the policy model is like the ChatGPT's brain. Now, here is where the action happens. The training model is like a back and forth chat. We are using something called reinforcement learning. Okay. Imagine ChatGPT is in a conversation. So every action it takes, it gets reviewed by the reward model. And reward model is like a super smart judge and uses a fancy algorithm called proximal policy optimization to decide what's a good response and what's a bad response. PPO works like a coach. It helps ChatGPT gets better at picking the best responses. And it does this by taking something into account called advantage function, which measures how much better one response is compared to all the other possible ones. And here is the important point. PPO makes sure that ChatGPT learns gradually in small proximal steps so it doesn't mess big time and keeps giving awesome answers. But there is a little hiccup called over optimization or overthinking. It's when the reward system gives out higher score even when the model is doing things we don't actually want it to do. Think of it like this: the policy, that is ChatGPT, exploits the gaps or problems in the reward system, and that's not a good thing. It's a bit like when the measuring stick becomes the target itself and stops being a good measure. That's called a Goodhart's law, by the way. Here is where it gets interesting. To tackle this issue, OpenAI added something extra to the PPO model called KL divergence or callback labeler divergence. This is like a fancy measure of the difference between two probability distributions. It tells you how much information is lost when one thing tries to guess the other. And guess what? The In the world of machine learning, this scale divergence is pretty damn useful. It's used for stuff like clustering, spotting anomalies, creating models that generate data. To keep the PPO model in check, they punish it if the KL divergence is too high between the RL, the real reinforcement learning policy, and the SFT, supervised fine-tuning model. Once ChatGPT is done with this final piece, the model is all set to go, and it's going to be mind blowing.
ChatGPT is really smart, but it still has a lot of room to get better. Sometimes it might say things that are not true and cannot give you links to where it has found its information. Also, it works best when you ask questions in a very specific way. But don't worry, OpenAI is working on making it even better in newer versions like GPT-4. So stay tuned and thanks for watching.